We can get started. I think I see Rekel sharing.
Yeah.
Yeah, so if you can take us through, I guess, uses of L, I think.
Yeah, just have a few examples.
Good, cool. Then we'll start off from where little bit, we'll move back a little bit and then keep going just so we can have context. But go ahead, Rekel.
Cool, sounds good. Yeah, just basically have two examples that I could pull out for this time, which was kind of different from just using a list. The first one, which we kind of pointed out last time, was that trying to add something to the front. And this is something we couldn't do with lists. But if you remember, like how transforms are kind of applied is you have these in the data block which have these type transforms, item transforms, and batch transforms. And item transforms, the reason why this is already present is that by default, you know that every operation that you would want to do would be followed by the two tensor transform, converting it to a tensor, and then applying whatever you want to apply. So Jeremy kind of removes that out and uh, pulls that out as kind of like a default transform. And now whatever item transform you apply, I'll actually get appended after this two tensor transform. So this is kind of having something appended like towards the front of the list,
So,
which
Rekel, so the two tensor mean he takes every item in the transform block and converts it to a tensor and then converts it next to whatever the item transform
right, because
encode says.
right. So the reason would be like probably, let's say item transform basically would be something like resize. Let's say you want to resize each and every image so that they'll all be the same size. So then you can go ahead and apply like batch transforms. You're going to be using like Torch Vision, I'm sorry, PyTorch or one of those to, let's say, resize. And those will operate only like, I think if you bring them down to like the tensors. So it's nice to like do that first. And then after that, you apply whatever you want to do on that. So that is why like this is kind of like a common factor in that sense. Like you would always want to apply this first and then only do the rest of the things. So hence it kind of makes sense to pull it out like this. That is the first example. And the second one is, if you kind of remember what index splitter was, that basically is if you're given, which example was this? I think Camvid is kind of split like this, if I'm not wrong. In essence, basically, let's say you have these tend to be, let's say, your training set, and you're given 0, 1, 2 indices as the validation set. And you're trying to pull out what your training set is. That's one example where like you would use your index splitter. And with index splitter here, what we're trying to look at is use list is equal to true, that functionality, what that does. So index splitter, if we quickly look at what it does is you pass in the indices which are there in your validation set. You have this in a function which basically is going to just take this set diff, which is whatever is there in O, and subtract, in that sense, remove whatever is there in your validation, and then return that as your training index. So as an example, if you look at it, if your whole O, that is basically your whole training, I mean, your whole data set is 0 to 9, you set your validation as 0, 1, 2, then you know that your training has to be 3 to 9. So that's what index splitter does. In essence, that's what a set diff does. Now to look at the functionality of this, it's returning an L, and both of them basically are doing use list is equal to true. So I set it up as 0 to 9 validation, 0 to 2, and index splitter pass in my validation indices plus in all the whole data set. And this is what it returns. And this kind of makes sense. This is what we passed in, 3 for the validation and 7 of them coming out for the training and training indices. Now, now to look at what happens if you don't pass use list is equal to true, this is the exact same thing, just not passing use list is equal to true, and same split. You can see this comes back fine because that's how I've set up the validation. So nothing interesting on that side. But what's interesting is on the training. And you can see if you don't pass use list is equal to true, it's counting this as one, which basically means it's like passing this as an array, I mean, like a list of a list, and it's not opening it up. And this is not the behavior you would really want. What you would want is this, right? You want back each of these 7 elements. You could use this, you would have to like index into the first array. So you'll have to do something like if you want to pull out the first element, here we would have done just square bracket 0. Here you would have to do like square brackets of 0, comma I mean square brackets of 0
Zero,
followed
zero.
by square brackets of 0. So it's kind of
By the way,
inconvenient.
that's something he calls. In fact, if you recall, we spent quite some time understanding what this was, and we'll go over
Mm-hmm.
that
Right.
example towards the end of last year. The unwrapping, he calls it
Correct.
unwrap,
Unwrapping.
and in this
Mm-hmm.
case, it if you don't give use list is true, it does not unwrap. It treats the array as an array, or it treats, in this case, the list of indices as a single array.
Right. So yeah, unwrapping kind of is that keyword there that happens here. I was trying to find out what exactly does this. I'm not completely sure, but I think when you're running code, Srinivas, we can look. And don't know if
Yeah,
this
in
is
fact,
still.
that's where I said we can back up, and in fact, your thing had a PDB set trace. I removed that, but we can stare at the
Okay.
code, look at the
Yeah.
examples, and then if necessary, we can do the set trace. And for
Yep.
it basically, yeah, we'll look at the code and then
Right. Yeah. I think this, if you just wrap that in that list, that is what kind of unwraps it. But yeah, when we're
yeah,
running,
if you put a list, then it'll lists always unwrap,
okay.
whereas L does not unwrap because his, in fact, it's very interesting that you found the one use case where uh, it requires L to unwrap.
Mm-hmm.
But Jeremy's claim is that in most instances in data science applications, you do not, this, because this is an index, you want it unwrapped.
Correct.
Typically, if it's an array, you don't want the array elements unwrapped, whereas a list will do the unwrapping as a default.
Mm-hmm.
And therefore, since the default is use list is false in an L, then the default use case would be that the array stays as it is and doesn't get unwrapped.
All right. Okay. Cool. Yeah. So yeah, those are like those two ones that I was able to find.
Yeah, no,
Um,
that's interesting because I think you hit on the one use case where of indices, probably masks are like that, but he has a mask IDX anyways. So
right. Right. So yeah, that yeah, that in the I forgot which one uses which. One of them do, but yeah, I mean, kind of it's the same functionality.
yeah, when you want an index, you don't want it as an array, you want it as
Correct.
individual indices. So
Right. So yeah, those are the two things that I have for this time.
cool.
Mm,
That's interesting. And we'll go to uh, one. It's from home screen. Let me know when you can see my screen.
Yep, can see it.
Okay, so that's where I actually stopped at kind of the L code. And in fact, I was just sharing. In fact, if you see this, we had set the import PDB and stuff, which I don't necessarily want right now. Let's see there. There's another one.
I forgot that was the notebook that was shared. That's why my changes are showing up.
Yeah, yeah.
Oh, okay.
That's what we were playing with last time, right?
Right,
Seeing
right,
that
yeah.
it creates the new and then creates the items. And then this is where what you were saying somewhat, and we'll go through the examples that would make it much more clear. But here it supports multiple indices because checks whether what is passed into get item is an indexer or not. And if it's an indexer, then the indexer is something that allows you to index. But if it meaning a single value type thing, whereas if it's not an indexer, then it'll deal with it differently. And the underscore get IDX is here is where it checks. It does kind of again there's that I need to comment out, and we can come back and play with it if needed. But if the indexer, then check whether this has an ilock. If not, return self.items I, not indexer, and if mask to IDs, then if it's a boolean, it will convert it to indexes, and then it checks for ilock or array. And if it's neither, then it goes through a comprehension of whatever is in self.items. And the self.items is because L uses collection base collection or collection base class as a class that it inherits from. Therefore, what is passed into L is converted to its, and remember that because of get itra, the underscore default, so it passes it to self.items, and therefore um, it becomes self.items. And then here is another twist to what you just showed the Raquel is if useless is not none, and if the items are not an array, then the items are converted to a list. If useless is true, it's converted to a list of items, right? So this is what converts it to a list, and then if use list, otherwise it just as listify. And then I think I have listify up above that we can go look at, but listify converts everything to a list, but handles arrays, handles special cases, so other things as well. If we want to look at that, let me see whether I have listify up above. I thought I did. Well, I could just do it again here at no harm instead of scrolling up and searching for it. Just one. Uh, Yeah. So if you see what list, and by the way, he has a bunch of these. There is listify, setify, tuplify, and all are kind of similar. But listify, so it takes an object, and then if there is rest, there's star rest, so it splits that. And then again, he uses the same concept of a use list, false, and again match. You'll see what match does even for an L. And then, so it converts O to a list. So if rest, then you add rest to O, meaning you append. And then if it's useless, then it converts it to a list directly. Otherwise, if it's none, the result returned is an empty list. If it's already a list, then the result returned is the list itself because it's already a list. If it's a string or an array, then the result is the string or the array is put into a list and returned. Otherwise, if it's an iterable, then you make it into a list. And otherwise, you just put O into a list if none of the above is true. So in every instance, eventually you get a list. But if it's an array, it's stuck, the array is stuck into a list as an array, not unwrapped. So when you have that thing, it'll become, if it's an array, then it'll become, a single entry into a list. The string, it'll again be a string that's stuck into a list. And then the match thing is it'll match to the length. And if the length of the result is 1, then it'll broadcast it to the length of match. And if you don't provide that, then it'll complain. If match is not 1 and the length doesn't match of what you have provided and what your O and the length of match doesn't match unless O is 1, then it'll complain. If the length of O and match is the same, then it sorry, no, I am wrong. If match is a collection, then it converts match to a list, to its length. So it'll take the length of match. And if the length of the result you get from this is 1, that means if it's a single element, then it will duplicate the element to the length that you've specified in match. So it will make the result as long as your match example that you gave, meaning by specifying match, you're actually specifying the length of what you want this to be when you specify O to be a single element. But if it's not a single element, so then it will complain because length of result should match this. If it doesn't, then it will say match length mismatch.
So what is that first if actually doing there? It's not affecting result in any way, right?
Um, but it changes O, so it changes everything subsequent because it all depends on O.
No, I mean the first if in the if match is not none.
Oh, here. Okay, sorry. You're saying here.
Yeah,
If
the
match
first
is
if
not
there.
none. Oh, it'll do all this if only if match is not, if match is a non-none value.
Correct. And it's doing just match is equal to length of match
Mhm.
and really never use that match after that, right? And you're returning just result back.
Yeah, no, you're returning result times match, meaning you'll duplicate result to the length of what match length that you provided. You'll see the usage in a
Oh,
test.
okay. Okay.
So you see what's happening here. You convert, so match what you give is typically something which has a length that you want
Mhm.
this to be stretched out to this length.
Okay.
Okay. So if you provide an array or you want, if this is, yeah, so it's simple length. So it will only do the length part. So if you provide O and you want a single value, let's say, and you provide this to be length of, I don't know, 25, then
Mm-hmm.
it'll say match is 25 if match is a collection, right?
Mm-hmm.
Then if length of result, so what you've got here finally
I see.
is
Okay.
1, then it'll broadcast it to the length of match.
Okay. Right. Okay. Makes sense. Okay.
Otherwise, if it'll complain. And this whole match thing happens only if match is not match.
Mm-hmm.
But I haven't, I mean, he obviously tests it, but it'd be interesting to see whether there are any in the wild fast AI applications where he just uses match.
So it's both, right? If match is not none, and basically if your result is,
A
or
single
and
single
yeah,
value.
exactly. Length of
Yeah,
result
yeah,
is also okay.
yeah. That's what Listify does. Okay, but moving on. So we were looking at L. Let me rerun L. Let's see any more import PDBs in the code. Okay, it isn't there. Let's run this guy. Okay, so also if you see here, see if you set it and remember that in this case we can set multiple items. So can be list of indices or mass or int. So we'll see that and he has to handle that in the code. So if it's a single int, then obviously you can just set it. Otherwise, you'll have to check whether an index is an L. If it's an L, then just make the index an index because an L is an L, as we saw, whereas a list is not a list of a list isn't a list, but an L of L is an L, and the index within L will be just IDX. Otherwise, listify the IDX. Um, so let's and, and then we'll start looking at. We had already looked at this, but I think to just get context, I thought it'd be better to go through it again. The one thing which he does here, and you can look at the, is he, for some reason, at least I saw that there is a simpler way apparently where you can inspect the signature and here pickle dumps it and pickle loads it, but I don't think there's necessary. I saw somewhere that there's an easier way to do it, but he still does it this way for whatever reason. But that's just to ensure that the signature of L that he gets back is what he exactly wants. And the other thing which he's doing here is ensuring that L is registered as a sequence so that he can use things like uh, randomizing stuff and so on. So here's where he begins to apply usage of L. So you can see L of a dictionary is just the items within the dict. It takes these item or the dict's items and L of D, and then item got one. The maps the absolute value on it, and then he filters it with greater than 4, and then he sums it. So given that its item got 1 because there's a dict, so the keys is not what you want, which will be item got 0. Item got 1 will be the values, and you map absolute on the values, and you take the values greater than 4 and you sum them, so it'll be 9 plus 6 plus 5, and that's what he gets as the result. But what is interesting, and you'll see that a lot more as we do the methods, is you see the chaining he does here. You can just do LD item got map abs filter greater than 4 dot sum. And this would mean get the values in one of L that you've stuck in there, make the absolute values of those, filter it, and then sum them, which is pretty cool. And by the way, there are multiple things in FastAI that supports it. This greater than 4 thing is also something we touched on last time, that he's able to code, and we'll look at it in, I think, a different notebook, how the operators are coded in such a way that he converts it so that it can be chained in this way. Okay, so this rest of it, I think we touched on already, but if there are any questions, let me know. But there's just range of 12, and then the T, which is the L is the list. And obviously it's not equal because there's 11, and we already covered on the fact that the reverse method doesn't exist, but L delegates it to actual list, and list as a reverse, so he's able to do the T dot reverse, even though there is no reverse method in the L code if you look at the L code in the cell above. And then, you're just using set item to do this, and checking that you can set any at any index. The cool thing is you can do non-contiguous integer indices. So you can say, and you can't do this in L. So T35 is JK, which would mean that at index 3, the value of L of range 0 to 12, it's become J now, and at index 5, it's K. And you can check that they have changed. And then this check, like I mentioned before, just ensures that L of T and T are the same thing. So L of L is an L, and it's exactly the same L. It is the same object. It's not pointing to the same object. It is the same object. And that was something else I was wondering also, Rekha, something to keep in mind, or anyone else also, is where he actually uses that fact in the usage of L. And where it's helpful versus if it had been a list of a list wouldn't be a list, but an L of an L is an L. And obviously he has done it for a purpose. And I was curious where that comes in handy. And as I was mentioning before, um, it's you can check that L is a sequence because each instance T sequence will not complain, which means it is a sequence, which allows him to do things like use random dot sample from sample 3 items from T, and in order to execute random, I guess uh, this way you'd have to have the underlying thing to be a sequence. And I think I already put it, but this is where we were looking, or I kind of pointed to this thing that Rekil also highlighted, the usage of an array versus use list is true, because this is an array. And here we are not saying use list is true, we're just saying it's none. And we're giving it a data frame. And so, by the way, in this instance, we don't see much difference. It's just that we are indexing into it, into a pandas data frame, but you will begin to see. So if you say L array use list is none, then let's say T is 1, 2 will make it, I think this was for a different value of L. Let's print array so we know what we are sending into the L. So you can see that the array we're sending in is 0, 1, 2, 3, 4, 5, 6, 7, 8. And then when you say useless none, print T1, 2 would be these as a single array, as opposed to, I think if I were to do, see here, it's split, it unwraps. Yes. So instead of it being a single list of lists or array containing two rows, it splits the rows and gives you back two specific instances. Any questions? Okay, moving on. And then you can append, and as directly showed, you can add from the left, which is not something that you can do with. So you can do 5 plus t. So 5 gets added to the elements of L, and here a list is provided, here a tuple is provided, and then you can obviously do the multiplication operator. You can do the map and operator, but you could do this on a list too, but you can't add from the left on a list, and you also cannot negate. So the negation works on a L as well, which helps handling mass and Boolean values. So here you can see true, false, false changes to false to true when you negate an L. And then you'll see a lot more of these map zip methods. Oops, sorry. where you're zipping L1.cycle with T, and if you zip a range of 4 with one of cycle, then it just means that it'll give you 4 ones. And this just checks that T and T dot shuffle, uh, that T dot shuffle is just a shuffle T. Any questions? Okay, and then we move on to mapping. Um, you just map the negation operator. Um, in this next cell, it just gives you an example of where you can use a function and just apply to a particular, change the particular value A. And this is okay. And then this is where last time we were, and Rekil was helping us debug through this. If you do a list of array, and it's not immediately obvious because both of them show up very similarly when you print in this case, but as we've already seen, the unwrapping and the wrap, treating it as a single array versus unwrapping the elements is what is the difference that happens when you use a list versus when you use an L. So in this case, the list has unwrapped the 0 and the 1 as individual elements, whereas if you provide it to an L, it'll treat this as a single array having 2 elements. So here use list is true, will have 2 item list versus 1 tensor list or 1 array list. That's the key difference. Any questions? Just a sec. Oops. I think I stopped sharing. Go back to the, okay, so these were things where we were trying to determine the difference between, and this is where it shows how it handles it for a string, for individual elements, for an LFL. So here, let's take it element by element. So here you can see that L of 1, 2, 3 is just the elements 1, 2, and 3, or the list 1, 2, 3, I should say, to be precise. And L of 1, 2, 3 is again just 1, 2, 3. It's just the list, as I've been saying. And then it obviously L of 1, 2, 3 should not be equal to this. When a string is passed, because it's listified, you see that it retains it as a string. Whereas if it were a list, it would have split it into A, B, and C. It would have again unwrapped the string, whereas an L doesn't unwrap it. Okay, let's finish this before I save. And then this is just 0 to 3, 0, 1, 2, that's obvious. Here, O for O in range 0 to 3 is just the list 0, 1, 2 elements. Here, when it's array of 0, it's array of 0 entered into a list. We saw that particular code because of listify. Listify does this, and then L just takes in the listify value, so it becomes that. The value array 0 is stuck into the list, or yeah. And then if there are array 0 and array 1, then it's stuck into a list as array 0, array 1. And here's the interesting part. Test equal L of array of 0 dot and 1 dot 1. If you index into the 0th value of this L, then it will be the array which contains 2 elements. It will not be the unwrapped version. Whereas if you, and here is the key difference between uselist is true and not having uselist is true, because that's what is the case in the default situation. So when you do L array 0 dot 1 dot 1 and then you say uselist is true, then what you get is a list with 2 array elements, not a single array with 2 elements in it. So if we did L of, or if we did that 0 index into it, you will get this, just the array with a single element in it, right? So that's kind of the key difference between useless is true and useless not true is shown in the last 2 lines of that cell, right? So if you execute that guy, so here if I say L array 0, 1, 1 and the 0th element, it's the entire 2 element array, right? Which is what I'm showing here. And then, and it will, right? And then L array 0, 1, 1 use list is to actually unwraps it. So there are 2 elements now in the L. That's the key difference. And let's see. I think we jumped ahead a little too much. Yeah. So here you can see array range NP3, and you can see the difference between, again, we kind of did something similar up above, and it's the same thing. You print the array and you don't have a list. Otherwise, you say use list is none. And then that means it's provided a single array with 3 rows in it. The LT of 0 use list is true, on the other hand, will give you just the first row because it would unwrap. So you can see that it gave you just the first row. And then T of 0 use list is none, will give this row but as an array. So that's, we're just playing with various ways to indicate. Again, if you say T of 0, which is that guy, but you say use list is true, then it'll unwrap it to have 3 elements. But if you say use list is none, it'll return a single array of that entire row. I can go on, but that's the idea. Let's look at match. So what match is if match is not none, then the created list is the same length as match. So the idea is either by, if the length of items is 1, then the items is replicated. Otherwise, an error is raised if match and items are not already the same size. So this is the code we saw earlier on what it does even in Listify, and then it's the same thing when you provide L with this match parameter. So if you say match 1, 2, 3, it doesn't really care about what the elements are, it just, if you recall, listify just takes the length of match, multiplies, multiply meaning duplicates or makes this the same length as what match has and returns that. And if match is 2, 3 and L is 1, 2, then it again doesn't complain because the length is, because the length of match matches the length of what you send into L. If that's not the case, as in this third instance, then your test will fail because there'll be an error. So that's what match is used for. I'll keep an eye, or I'll look out for whether he has used match in the FastAI code. Um, oh, this is an interesting use case. So here, this is an obvious one. So L is 1, 2, 3, match is 1, 2, 3. It obviously doesn't complain and it says, okay, I have an L which has 3 elements, right? So that's obvious. But then if you give it, look at this, in this case, I thought was interesting, where if you give it a list of 1, 2, 3, and you say match 1, 2, 3, then the length of this is 3, but the length of this guy is a list of list, but obviously there is, this list has one element in it. So it broadcasts that and makes that and duplicates it. So it duplicates the 1, 2, 3 as you see here. I thought that's interesting thing to keep in mind of how that works. Any comment? Okay, moving along. I thought that's a interesting use case. For example, you give it an NP array and you give it a length, it actually duplicates the array. Remember that this is a single array in L. So it duplicates the array to match the length of match. Can anybody think of a use case where this will come in handy? Okay, and then let's see. Um, this is the test that I'm running to say that L of T and T are the same object. That is, it's exactly the same object. So test is L of T and T should pass. Whereas if you make a list 1, 1, 2, 3, 4, and you check whether list of list 1 is list 1, that will fail. Okay, and then the other thing to note is that an L is considered according to it to be equal to a list if they have the same elements, but it's never equal to the string or a set or a dict, even if they have the same elements. So here you see that it's equal, but these two are not equal even if they have the same elements. And then, yeah, so if you provide a list to, sorry, if you provide a dict to a L, it returns the keys of the dict. The methods of L are kind of interesting because it obviously set it up for a bunch of use cases which I'm interested in seeing. I'll search the code to see whether he uses them, but he sets up several very interesting use cases for the various methods of L. Um, Obviously, these are just um, checking that the indices, or if t is range of 12, then at the index you get the values, um, and there's a list of lists, and again you get the same list. You can slice it, you can use mask, and because false times 11, the last value is true, that means it's range of 12, so it's 0 to 11, so you get the 11th value, or the value 11 but inside of a list. So you can use Boolean indices to index into the L, and array of 3, the value 3. So that's fairly self-explanatory. This is the interesting thing as compared to a list that you can do with an L, is set multiple values to be using set item, multiple indices you can set the values of. So T of 4, 6 I made 0, so you can check that they become 0 at indices 4 and 6. And then you can give it a value 1 and 2, and then you check that they have actually gained the values 1 and 2. The other two things, which are these two are fairly important. L dot unique, obviously the code is helps you to get the unique values out of the elements that you're provided to L. So for example, dot unique of this tuple is just 1, 2, 3, 4. And that combined with the Value IDX helps you create the reverse dict and the vocab, because Value IDX basically says if you give it these values, then for each of the values you find the index. So for example, the value 3 is at the index 2, so you form a dict with key 3, which is the value of this guy, and that is at index 2. Whereas the value 1, which is this key, is at index 0, the value 2 is at index 1. And the combination of unique and val to IDX helps you build both the reverse dict and the vocab for most of your data set related things when you need to build a vocab of items. Any questions or comments? Anybody still? Okay, people are still around. I'm not talking to myself. Okay, let's see. Let's see. I don't know why I'm getting so many save failures today. Oh, is it because I've shared it, Raquel, to where?
Yeah, that's what I thought. I'm closing mine right now.
But that, were you making changes now?
No, nothing right
No,
now.
right? Then, yeah, then I don't know
But
why
as
it's.
you run, it's changing with the reference that I would have had. So maybe that's
Oh,
what's
I see, I
complaining.
see. So if you had made previously some changes, then it will try and save and some
Yeah, even
overwriting.
if I had not, yeah, exactly. Like just your cell numbers changing, I don't know if that itself
Yeah,
is creating an issue.
that, yeah, that's interesting. But I wonder why it doesn't just save the. Okay, so now here comes some very interesting things. I don't know again where he uses it, but see here is list of t. Let's just say this is the um, L has these values. You can then apply a filter using a lambda function and get the actual values. Now that's, you can do that to a list too. So what's the big oopty do? But you can say negate is true and get the opposite of what you provide to it as a function, which I think is quite good because I don't think you can do this with a list. Um, so you can say the same lambda function. So you can see that in the first case, it returned all the cases where the lambda function was true. In the second case, it returns all the values from L where the lambda function is not true. So you can see that O less than 5, it will return all the values where O is greater than 5. And here's the, oops, I did that. I ran that cell already. It's this cell I want to run. The next one is fairly cool because I don't think, or obviously, this was one of the reasons you had to go to NumPy and stuff. Only works in NumPy is an index into where the value is. So, for example, you can do l.argwhere. That's really cool because it returns the indices for when the items match. So for example, you can do the same thing. Here it was returning the actual values. Here it returns the indices for this set of values. So you can do t.argwhere and give it the function and it will return from t the in or it will return the indices from t where the function was true. And again, obviously, you can do negate equal true, in which case it will return the indices where corresponding to these values. So that's kind of a cool capability in L that you do not have in a basic list, which is like he says, in fact, he says that one of the basic ideas behind list is to add in NumPy-like functionality. So this is definitely a NumPy-like functionality. Now, here is the map operator that you can chain. So L.range4.map operator neg will give you these values, right? And then he begins to do some, I know where he would use this, but he says if F is a string, then you treat it, when you provide a string to map, it treats the string, it treats the string as a formatting function for what you provided before. So you can see he has provided a, pound, curly bracket pound within this. The curly brackets, I guess, are to ensure that it interprets that, but it's here range of 4, so it does 0, 1, 2, 3, but sticks in the pound in front. I don't know in what case you would use it to format. Um, let's see. Then if F is a dictionary or anything which has, I think more like you could say any iterable, although it doesn't, it seems like it doesn't require length, whereas typically an iterable would have a length. So you can do map the list of ABCD and it actually gives the list. I think it creates, this is getting it from what you map onto this range. Again, I do not, or I'd be interested in see where he uses that. Um, he plays some similar games with arg parameters that bind accepts. Again, do not know where it's used, but I could see these after this, where the functions he uses begin to become more relatable and probably more applicable. Let's see if I can think of these cases. So if you have, for example, a map dict, what it does, I thought this is fairly interesting, is it creates a dictionary with a mapping of the values. So for example, here you say, actually this first one is not that clear, but the second example makes it clear. If you have a range of 1 to 5 and you say map tip and you give it an operator, then the values of this are operator.neg applied on a range of 1 to 5. It means -1, -2, -3, -4. But the keys are this guy. So it's 1, 2, 3, 4 as the key, and the values resulting from the map dict as the values. So that could be a handy thing to create a dict with some values that you create from a function or an operator you provide into a map dict, and you'll get back the indices from here and the values from here. So that's useful. Um, and then there's a zip function that goes with an L. Just this is similar to what you could do with a list. So I don't think that's very fancy. I mean, basically you do a zip on an L and it zips the elements within the L. And but this is interesting. If cycled is true, then it replicates the shorter length list or tuple or whatever you provide to L to match the longer one. So for example, if cycled is true, you will see that because there's 4 elements here, it duplicates the A to match the 4. So A is duplicated. But if cycled is false, which I believe is the default, then it does the same thing as what zip default does, which is it's zip shortest. Okay, and then here's some other clever ones that he does, which is instead of just doing a map, or instead of just doing a zip, he does a map zip and then a map zip width, which are fairly interesting um, applications of what you can do. Oops. Yeah, so map zip combines mapping something with zipping something. So that's kind of cool because you can say map zip and provide an operator. And what it does, it zips this and then does the operator on the zipped elements. So for example, when you zip these two lists, then you would get 1, 2, 2, 3, 3, 4. And then you do an operator dot mul, then it multiplies the 1 and the 2. So first is 2, and it multiplies the 2 and the 3, which is the 6, and the 3 and the 4, which is the 12. Right? So it does the map zip, and then you can provide the operator input to it that does um, And then subsequently, he also does zip width, which is again, so if B is a 3-entry list, and then you have an L of 1, 2, 3, and you zip with B, then it zips your elements of L with the elements of B and returns an L. So you can see that when you do that, what results is 1 and 0, then the element 2 combined with 1 and 3 combined with this, which is a 2, 2 entry, right? So that's zip width. And you can obviously use zip width along with an operator. So if you do test equal to L123 map zip width operator mul 234, then you get the same thing that you saw earlier.
The previous one, will only zip not work? Like, why zip width?
Good question. Let's try. Um, you're saying just zip L123 with just that?
Right.
Let's try. Good question. Come on. Very annoying. Keep on saving.
Should probably stop
Sharing.
access to share. Yeah, exactly. Just turn that off on your side. Don't know if someone else also has it open, and then see if
Well,
that makes a difference.
but I thought you downloaded it, right? But it's still, I guess, if it sees it as shared, then it keeps multiple copies and probably gets confused or is just being.
Yeah, because it looks like my changes were being reflected on yours, right? So,
Yeah, that is true. Okay, we'll see whether that works. Let's see any better. So you're saying, let's try t dot zip b, and we want to make that, well, actually we want to make it t, let's call it t1 just to differentiate, is, let's try same thing as the L of 1, 2, 3. Let's zip b. Oops. Two. Then like, why? You can't zip an L and unless, oh, so is it because of L?
mm,
L doesn't support zip. Let's see. Let's zip with this response. Zip number argument number one must support iteration. If it has get items or iter, then NL line, it should support iteration, right? Because it is L is L of 1, 2, 3 would. I'm not doing anything obviously stupid,
Right,
am
I
I?
think it's just that B is like that array of array, right?
Yeah, but it says argument one, which would I would think is the L argument that is complaining about. I can try B dot zip L. Will that work? You know what I'm saying?
Yeah, I see what you're saying. Yeah, should give that a shot. I don't know what.
I mean, because it says first argument, right? First argument to zip, is it B or is it L? Oh, come on. B dot zip L.
Are you missing a pair of brackets there around L?
Oh, am I? Oh, because this L should have, oops, it's not there. There, right?
And right, but
Like
yeah,
good.
yeah, but it's complainers that that list doesn't have zip, which makes sense. So zip it looks like when it's like a list of lists comes in handy.
Zip, you can zip to list though, right?
You can use zip as a function, but it's not a method of list.
Attribute, yeah, correct.
Sorry, Arthur?
You can use zip as a function, but list doesn't have a method zip. So you
Zip
can
of
zip
B, comma.
B,
Ah,
L.
L, yeah, I can try that. Okay, yeah, that's a good point. Yes. So I can do zip B, comma L 1, 2, 3 and see whether that works. Oh, I have to list it. Okay. Yeah. But what if I, well, let me try this first. Oops, wrong. Okay. That, yeah, I think that should do it. Did the same thing, right?
Yeah.
Except just the order. I mean, I could have flipped the order.
Mm-hmm.
That doesn't matter.
But yeah, this is more to do with native zip rather than zip with from list. I mean, from capital L.
Yeah, that's true.
Right.
Zip it is a method, but to your point, you could just have done this, right? And in fact, I was also wondering whether we could do this, which is command move. Right?
Mm-hmm.
Oh no, where am I zipping?
Yeah.
Of
Print of zip rather.
zip of the guy. One more. Am I right?
Mm-hmm.
Yeah, so that works. Huh? What? Ah, yeah. It gave the same thing as above.
Yeah.
But I guess this is Jeremy being Jeremy. It's probably too much typing for him. He likes zip with, right? Because this you have to do L open zip function L blah blah blah. Whereas you can just say L dot zip with.
Mm.
You see, this is a lot simpler to type than what we just did here. You have to align so many brackets and all that kind of stuff. He hates that crap. But it is. But to your point, it works this way too. But there is a zip with method, I guess, which makes it easier to zip with method of L, whereas a
Right.
list doesn't have a zip method. You have to do it as a function. Interesting. And then he has a map zip with. So that's, you do a map zip width on an L, provide an operator, and then it does all this fancy stuff, basically. But I think the next one is something that I think is there are two things that Jemmy does, which specifically the next two, I think, is the item got and attribute got, which I think are both fairly useful thing because an item got he abstracts operator dot item getter, okay, and makes it much easier to get your items. So you can see what it does. It creates a new L with the item index of all items. So item got is essentially operator dot item getter to every item in L and then return that. So remember that T is oops, T is what I printed above. So it's 1, 0 because we zip with, so it's those elements. And then when you do item got 1, you're actually getting back B. But the point is that with an L, having this item got and just providing it uh, that method with an index is really useful. It's a simple way to do the operator dot item getter. Simpler, I guess. Right? And you can do the exact same thing, just like, at least for me, it's easier to remember, oh, item got, okay, instead of trying to remember operator dot item getter, which I often forget that it exists. And L dot attribute got is just getting the attribute. So item got and attribute got are just operator dot item getter, and then this is a little bit more complicated, the attribute, but basically attribute is just getting the attribute of a key, or sorry, attribute of or the value k for the dix, or the attribute in a simple namespace. So for example, if you have a namespace with A3B4 and A1B2, and you say, give me the LA attribute B, then you're going to get the 4 and 2. I wish he had used something else other than an A here, because that confuses with this A. I'm going to make it, let's say, wow, I don't know whether it's changed it somewhere, but anyway, let's call this NM or something. Right, so you can see that you can do in any kind of a namespace, you can do an attribute and it will give you the, if it's a dictionary, the values. If it's, attributes within a class, it will give you those attributes, which I think is pretty cool. Easy way to get hold of them. So for example, when items are a dict, so B ID ID is 17, then you can say lb.attribute ID and it'll give you the 15 and the 17. And if you do l.attribute name, then it'll give you nbdev and fastcore. So those are things which at least I find in l.item.got and attribute are fairly easy to remember and recall to use. Okay, and then let's see, he also has a sorted much like a list does. And oh, he's done, so I have to change, I guess, this to nm. See, so if you, sorry,
you need to change it within the L.
Here,
right?
Yeah. What was it here before?
A.
So both of them need to change, right?
I think you're sorting on that key, right? So that.
Oh, yeah. See, that's what makes it confusing. So the key is still A.
And your nm will be not in quotes now, since it's the value, not the string.
Yeah, that's what. Okay, let's see. Yeah. Yep. And then splits, similar to list splits, but returns an L. And again, if you recall, it's a class method because, it's a different way of constructing an L. So it's a constructor, duplicate constructor, or another way of constructing. That's why it's a class method. So if we go up and look, he's probably made a split as a class method of L. So if you do L split ABC, then you get the individual elements. And I was just, but you have to do L dot split. Whereas if you just do list of ABC, it'll give you it'll split it. Which is why in listify, he takes the string and sticks it into a list as is versus unwrapping them, quote unquote. Whereas a list unwraps right away. That was something that I had to recall. And that's something to watch out for because strings won't unwrap when you use an L. And then same as range, another way to class constructor type thing. So range of 3, L range 1. And you're just checking that the type of range when you do an L and tuple or list is the same. Doesn't change. Let's see, what are the methods? And then you can use you can concat. This is fairly interesting too. So when you concat, you get all of them concatenated. So L of 5, 6, then just 4, 0, 1, 2, 3. You concat them and you get a range of 7 because there are 7 elements, 0 to 6. And then copy is the same as a list, but just returns an L. So you can again do the same thing and with a copy instead of concat, and it'll say he's just checking the t.concat, which was Like I range of 7 and range of 7 is the same. Then map first. So it's the first element of map filter. And key dot map first lambda O2. So it'll be multiplied by 2 if O is greater than 2. So it'll be that guy first. No? Else none. That's equal to 6. Oh, if O is greater than 2. Okay, so that means it'll take first element greater than 2, which is this guy, and multiply by 2, and it results in a 6. Again, I don't know where you would use a map first, but some of these functions seem fairly unique or specialized with use cases not jumping up.
So in that, if T is 0, 1, 2, 3, 4, 5, the test equals will not change still because it's mapping only 3, or will it be mapping like 3, 4,
Good question. That's right. You're saying because it's mapped first, right? So
Yeah,
it
what
should be only that, and it should still pass. Yep.
Cool. Okay.
Ignores the rest. Yeah. And then let's see. Set attributes. So call set attribute on all items. So simple namespace, set the attributes foo and bar, and then check attribute foo is set to bar, and now let's see. Oh, because of two namespaces you get bar. I was confused as to why there are two bars, but that's because he has made two namespaces, in each of which he sets the attribute foo to bar. Okay. So this is to set attributes within a namespace using an L. Again, I would be very interested on where he uses it. I think I'll probably spend a day or two trying to figure out how many of these he actually uses. It'd be interesting to see the use cases where it helps. Okay, so I think that let's see. And then the configs, I don't think are I haven't looked at too much to see where it's just reading and writing some config files, and I didn't see him kind of talk about it or refer to it in any of his things. Have you encountered? It seems it's similar to the argument parser, arg parser, and that kind of stuff. Have any of you encountered config parser usage anywhere? That you can share? Because I looked, I couldn't fine. So I didn't dive into this config portion of this notebook. If anybody has any comments or want to go into it and explain how and what it does, I mean, it's clear what it would be doing or where it's used, right? Settings, dig to a new config file or overwrite the existing one. But it seems to have to do with, configuring some setup related stuff that he uses for fast core, but I haven't seen it.
I think it is for FastAI in itself for your user settings, not
Yeah,
for
so
fastcore.
it's for configuring the FastAI and fast core settings.
No, more likely where your default directory for data and models, but it is used in FastAI for your default config. I don't
Hmm.
think it is for fastcore itself.
Okay. Yeah, because I haven't really, I've played with many files, but I haven't looked at what he has in the ini temp.ini files.
Mhm.
So yeah, I haven't spent time looking at that config thing. Okay. Well, next time what I'd like to do, or we can take a look very quickly at the code. I won't run it because it's and I'll just the next notebook, and in fact it's somewhat confusing because I think over time, by the time I downloaded and we started into the discussions of the foundations, Jemmy has moved code from foundations into this notebook called the basics, because GetAtra, when I downloaded, was in the foundations notebook. It's now in this basics notebook. Um, so he's been, obviously he's still changing fast core or making changes to it and improving it. Um, but there are several things here. There's a very handy make class, um, and we look at it very quickly if this thing comes up, or else we can stop here, yourself a break before we head off to, it did come up. So I'll run this the next time and we'll go over and kind of get into the details. But right now I'll just share with you um, some very simple things that he does. This is an interesting function that he creates as well called if none. Um, and you can see what the code does. So if A is none, then it chooses B. Otherwise, if so, the English version of it is if A has a value, it's chosen. If it's none, B is chosen. Right. Um, the interesting thing is the comment that he has below, which is in itself interesting, that if you do this versus if you just write the code as this guy, if A is none, B, if A is none, else A, then one of the things he points out is in this case, both A and B are evaluated if you put it as a function. Whereas if you write it out as an expression like this, he says that it doesn't do if using the if version directly. So I've seen him use if none quite a bit in the code. So that means between these, if this is none, then use B. So that's where here it will say if none, none 1, then it'll pick 1. If 2, then 2. And then another kind of function he calls maybe atra. So maybe atra says get atra of O if the atra exists, otherwise give the object itself. So that's what it says here. Return the attribute atra for object O, and if it doesn't exist, the default supplied is the object itself. I think this is something he has used in a couple of instances also that I recall. I might have to go.
Comment with the none thing. Be careful because Python will evaluate both A and B when calling if none, which it doesn't do if using the if version directly.
Sorry, so you're saying what
Right.
is meant by that? So I'll tell you what at least I took away from it, right? I took away that um, this this is what it would be. So if you write it out instead of this, you just want um, B if A is none, right?
Right.
So you would say if A, in fact, you just use that expression itself, but B if A is none, else A. And in that case, he's saying that it will only evaluate A, not evaluate B,
Correct.
right? It will just give you B.
Right. That is if you use, he says when it.
Not as a function.
Yeah, correct. When you're
not in this context.
Right.
If you do this, it will also evaluate B.
Oh, I don't see. Yeah, okay. That's the part I don't understand or see happening over there. Like what
or why it happens, right?
Yeah, exactly. Or why.
Yeah, but that's, I think we'll have to investigate the way Python is built when you code it as a function.
Cool. Okay.
Right? Because it seems to be a difference between an expression like that, like forget the return part, like B if A is none, else A, and if none A B, and then return B if A is none, else A. I don't know whether it's the return that does it or it's a Python thing that whether it's a function that causes it. That's a good question.
Yeah, the be careful part is what kind of sticks out. Like when.
Yes, but that I thought was because if you that it's more that if for whatever reason you don't want B to be evaluated, this is not a safe thing to do.
I see. Okay.
Right? Because in the other instance, you wouldn't evaluate B. But if you evaluate B and it causes an error of some kind, right, then you will get the error. Whereas if you just coded it as an expression, that will not happen.
I see. Okay.
That's what at least I took away. That his be careful is because in one case, B will not get evaluated. In this context, it will just return B. So then, whereas here it will evaluate B, and in evaluate meaning, it is that's where, when it will cause an error when B is evaluated is a good question. If B is some value that it's not expecting or is a none or a blank, that's something which is under what conditions will it give the error when it's evaluated?
I think it is before the cal because it will be the thing you pass there will be evaluated before passing it to the if none method. So when you enter the if none method, A and B already has its value evaluated.
So
right, but that would be true even if you just had this expression though, right?
No, because if suppose you write the normal if else
Mm-hmm.
and the else part is not evaluated, so your function will not be called because you are writing out all uh, and the and say the compiler or well the interpreter will not execute
Mm-hmm.
that part. But because this is a function, the values you are passing to a function are evaluated first before you pass them to if not you will need to do
So it is the fact that, so it's that fact that you just mentioned, that functions evaluate parameters passed to it. It's
yep,
that
yep.
rule that will cause B to be evaluated.
Uh-huh.
Or
So
or stated another way, you can only pass parameters which are already evaluated or
yep.
have values to a function. Okay.
Yes, so that is why it will be evaluated, but
Ah,
before calling the if none. Well,
yeah,
what you
meaning,
said.
before
Yes,
whether
yes.
it is none or whatever, but B will still be evaluated.
Yep, yep.
Yeah. And if you don't want to evaluate B, then this is not a safe thing to do,
Indeed.
right? Because that's the key difference he's pointing out. Because, like you said, if this is written out as a if else loop, then the B part will just be ignored.
Yes.
Yeah. Okay.
Right. So yeah, I was just doing like if none 10 comma 10 by 0,
Mm-hmm.
and that will break. But if you just throw it in the if,
Mm-hmm.
I
It will
just,
never evaluate the 10 comma
yeah,
0.
exactly.
Yeah.
So yeah, cool. I wonder where the use case for this one is also.
Yeah. But I have seen him use this though.
Yeah, I
You
mean,
know,
yeah, I've seen him
what?
use if none, but I'm about this specific case
Oh,
about be
the
careful.
B
Yeah.
evaluate. Yeah, yeah, that's a good question. Yeah, 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 yeah. But
I remember he talked in the discourse. There is a little talk about that. That he say, oh, I will just or someone suggested this if non thing because I don't remember if it was for iterators or something like that, but he wanted to do like more, I guess, functional. Uh,
programming type thing.
yeah, yes,
Yeah.
and he say, ah, well, we can do it this way, and he did make the function, and I think he replaced the places where he is used.
So you're saying if you do functional programming and then you might run into issues with um,
No, I mean he talked about this function. Maybe if later I search and find
okay. Yeah,
the
if you could post in Slack
yeah,
where
we'll
you
try
find the
to find.
discourse discussion. Yeah, that'd
Yep,
be
yep,
cool. Yep,
yep.
that'd be great. Thanks. Yeah. Okay. And I think, we have about 10 minutes, but we'll stop here. We'll start with kind of discussing my attribute and basic repo. This is kind of a cool thing that he builds. And then based on it, the other thing that he goes on to build in this notebook mainly is, given a set of fields and stuff, he builds actually a class. So there is a make class. Actually, you begin to see the listify code, which we looked at before, so we can kind of explore that. But we kind of looked at it already. But today, but we can look at that in little detail, and then how that works. Tuplify, where the true and false, booleans, null type. This is again an interesting thing he introduces. So a bunch of miscellany of functions, but the big one that we'll go through in the beginning, but the big one that's hiding here is dynamically create a class and then adding the class to the module that you are in. So this is, at least again, um, for me, it seemed like a fairly simple API to create a class on the fly and then stick the class into the module that you're using, which is pretty cool. If you have used or are familiar with data classes, it's somewhat like that, but data classes have, I think, more capabilities, therefore are a little bit more complicated. I would think the few times I have tried to program using data classes, but they also have more capabilities, I think. Very useful. That's something else we can look at in this context. I'll create a couple of pointers to data classes and we can kind of compare data class and its usage compared to what he does, which is get class, and then he has a decorator called a make class where he uses the text. Yeah, you see that make class and get class. So we'll look at the details of that and the rest of this notebook next time. Okay, thanks everybody. Thanks for joining, and hopefully my things will save faster next time, so we spend less time on it and more time working through the notebook. Cool. Thank you, and we'll see you all next week. Have a good
Happy New Year.
rest of the week. Happy New Year. Thanks to you. Same to you as
Thanks.
well.